Hi, my name is Michael Kurtz. This is my second explainer video, and I was assigned the soccer ball problem, which goes, suppose a soccer player punts the ball from a distance of 32 meters toward the goal. Find the initial speed of the ball if it passes over the goal 2.4 meters above the ground, given the initial direction to be 40 degrees above horizontal. So I decided to draw that out here, and here we have little stick figure soccer guy kicking the soccer ball at an angle of 40 degrees up in the air. This is its path towards the goal. This dashed line is the goal here, and it crosses over the goal line at 2.4 meters in height and at a distance of 32 meters. So, and then here we have our given acceleration, which is negative 9.8, which is going to stay constant because I assume this is taking place on Earth. There's no Mars Soccer League. So our gravity is negative 9.8 meters per second squared. So we start off with two equations. Our first equation is the initial velocity in the x direction equals the initial velocity times the cosine of our given angle. And our other equation is our final distance in the x direction minus the initial distance in the x direction equals the initial velocity in the x direction times time. So we put these together and we have negative x, not negative x, our final distance in the x direction minus our initial distance in the x direction equals our initial velocity times the cosine of theta times time. So that is our final equation right there. Ignore this stuff. Now we want to solve for time. In order to solve for time, we need to divide both sides by the initial velocity times the cosine of our given angle. See, we divide both sides here and we get time equals the final distance in the x direction minus the initial distance in the x direction divided by our initial velocity times the cosine of theta. Now, we need to save this for later because we will be inputting it into another equation. So here we start off with another equation which we will begin to work out in order to solve for our initial velocity. Trust me, we're getting there. So our initial velocity in the y direction equals the initial velocity times the sine of times our given angle. And our other equation that we're going to begin working in here is the final distance in the y direction minus the initial distance in the y direction equals velocity, the initial velocity of the y direction times time minus 1/2 times gravity as acceleration times time squared. So we begin to input our other equations into this to finally get our final equation. So we start with the final distance in the y direction minus the initial distance in the y direction equals the initial velocity times the sine of our given angle, which we got from up here, times our final distance in the x direction minus our initial distance in the x direction divided by our initial velocity times the cosine times our given angle. Then we subtract 1/2 times g, gravity, times our equation that we inputted here as well from up here, that equation, which is why I said we need this for later. We input that again here, and we have our final distance in the x direction minus our initial distance in the x direction, all divided by our initial velocity times the cosine of theta. That should be squared. I accidentally cropped the squared out of the picture here, but that is squared. Actually, matter of fact, why don't I put that in right now? Just a little 2. Yeah, see, squared. And then we solve this for our initial velocity, which we have here, here, and here. And trust me, it takes time to work it all out. And we get negative 1/2 times gravity times our final distance in the x direction minus our initial distance in the x direction squared divided by the cosine of theta squared times the final distance in the y direction minus the initial distance in the y direction subtracted by our final distance in the x direction minus our initial distance in the x direction times the tangent of our times our given angle. So when you input all the numbers into this, you get the initial velocity equals, also on this equation here, we have to take the square root of it because of this up here was squared. So in order to get our initial velocity, we have to take the square root. So this is all taking the square root of. So we have our initial velocity, we start with -1/2 times -9.8, which was our acceleration of gravity, times 32 meters minus 0 meters, the direction of the in the x direction, distance in the x direction, squared, divided by our cosine of times 40 degrees squared times 2.4 meters minus 0 meters, this is y direction, minus 32 meters times the tangent of 40 degrees. And when we input everything, we get 18.71 meters per second. Now, potential pitfalls on this problem here, it's a lot of variables you have to keep straight, and it's very important to make sure you remember what you're plugging in, where you're going to plug it in. Like you want to keep the equations you solve for here available so that you can refer back to them when you input for time later on or any other direct variable you have attempted to find. And another problem is order of operations for this whole problem is difficult because there are so many variables you're inputting, because there are so many things taking place. You just really need to make sure you keep your order of operations straight. So yeah, that was my explainer video, and hopefully that helped.